Tiara was able to explain to you what?
We kind of collaborated.
Oh, so together you kind of came up with
Yeah.
it. And now you think you understand it. Okay, so go ahead. Talk to us.
We thought what we saw worked was if it was a power of 2 or a multiple of 5, it seemed to be easy to convert, like, and not have like weird repeating numbers.
Why? Because they can go into powers of 10. And why is that important?
Because then if it can, like, go, if it can be converted to a fraction with a power of 10 at the bottom, then it can, you know that the decimal isn't going to be repeating because it's just going to be like a top whole number over that big power of 10.
Okay. Anybody follow what she's talking about? Let's take a look. Point 1, 2, 3, 4, 5. We'll try that. If I just cover these up, how do I read that number correctly? Don't go point 1. That's the shortcut method. What did your teacher tell you to pronounce, or how to say that? 1/10. What's that? 12 hundredths. That's 123 thousandths. That's 1,234 ten thousandths, and so on, right? Notice every one of these, if they're terminating decimals, we say tenth, hundredth, thousandth, some power of 10 in the denominator, right? So if I can convert the fraction into something that has a power of 10 in the denominator, then I can make it, or then I know it's a terminating fraction. Does that make sense? So, this right here, Rachel was the one that shared this. 8, when I prime factor it, I get 2 to the third. Can I multiply 2 to the third by something to get me a power of 10? Well, how do you get tens? Tens come from 2s and 5s. So notice, if I've used 3 powers of 2, it's going to take 3 powers of 5 to turn it into 3 powers of 10. Are you with me? Because 2s and 5 make up 10s. 3 powers of 2. So if I took this 3 powers of 2 and multiplied it by 3 powers of 5 on top and bottom, I'm going to get the 3 powers of 10 here, excuse me, and the equivalent one on top. Does that make sense? But over here, 12, how does it prime factor?
6 and
2
2.
squared times 3. So what can I multiply this by to turn it into a power of 10? Well, I could put a couple of 5s with the 2, and that would give me 100, but what am I going to multiply 3 by to turn it into a power of 10? You what?
You'd have to multiply by 10.
A 10?
No.
That wouldn't be a power of 10, it would be a multiple of 10. What am I going to multiply 3 by to turn it into 10 or 100 or 1,000 or whatever? I'm not going to find any whole numbers that will do that, right? Therefore, I can't turn this into a decimal that repeats because I can't get it to turn into one of those tenths, hundredths, thousandths, or whatever. Does that make sense? So, would someone like to raise their hand and say, here's how you do it?
Well, actually, I just have a question.
Oh, okay.
So on the homework, there's the 30 over 75.
30 over 75. And the 75, when we prime factor it, that's 25 times 3, and 25 is 2 5s. So it's 3 times 5 squared. And right off the bat, you would think what?
No. But then
No,
it's-
because I can't multiply a 3 by anything to turn it into a power of 10. So our first gut reaction is to say this fraction will repeat, but it doesn't. Why not?
Because
So you can simplify it.
Yes, this is what will go into both of these.
3, 5.
Well, 3 will, because 3 plus 0 is 3, and 7 plus 5 is 12, right? So guess what? The 3 up here will cancel with the 3 down here, making 10 over 25. And now, there aren't any factors down here other than 2 or 5. Does that make sense?
Yeah, I was just confused because it didn't work on the bottom, but it worked here, so I was like, what? But I got it.
Okay, so who could summarize this whole thing? How to tell, just looking at a fraction, whether or not it's going to terminate when you turn it to a decimal or repeat when you turn it into a decimal? Try it.
Isn't it if it's what is it, like a multiple, if 2 or 5 goes into the number, then it won't be repeating?
It will terminate?
Yes.
And-
if it's not, I don't know how to say it. I don't know.
Is she on the right track? Go ahead.
Well, can we just say if to have a non-repeating decimal, the prime factorization has to end with just 2's or 5's or 2's and 5's?
End with it?
Like,
It has to be,
you end up with just 2's.
Okay. When you prime factor it, all you have is
All you have is 2's
or,
and 5's.
or
2's and 5's.
or a combination of 2's and 5's. And if that's true, then,
Then it's not repeating.
in other words, it will
Terminate.
terminate. Okay?
Wouldn't that be in the simplest, like if you simplify it?
After, okay, so first of all, you want to simplify it, then you want to apply that. So if the simplified version of the fraction, equivalent version of the fraction, the denominator prime factors to 2's and or 5's, then it will terminate. Otherwise, it's going to repeat.
So, just so I'm clear, if we go back to the 5 over 12, 5/12, because the prime factorization would be a 3 or 2 2's.
We found a 3.
So that doesn't count because there is a 3 in it.
That's
Not
right.
just 2's or 5's or
Right.
a combo. of both.
Right. Because once I find anything other than 2's or 5's, and it's simplified, it's not going to terminate. Because I can't find anything to multiply that 3 by to turn it into a 10 or 100 or 1,000. Does that make sense?
Yes, it does.
Okay. Everybody okay? Got that written down? Yeah.
So just to make sure that I have it straight, so if the prime factorization ends with either 2's, 5's, or a combination of 2's,
Don't say ends with, because
the
then,
product
okay, if the prime factorization contains.
contains 2's, 5's, or a combination of 2's and 5's, the fraction will terminate. But if it contains a 3, it will be repeating. Is that
Or a
anything else?
7 or any other prime factor other than 2 or 5.
okay?
You could have an 11 or a whatever. Okay? And did you say simplify it first?
No.
That's part of it. Because otherwise, this one right here would be what? Repeating, and it's not. Okay? So, if the simplified fraction, and then has 2's or 5's or combinations of 2's or 5's, it will terminate. If it's got something other than 2's or 5's, it will not, and it will repeat. Okay. We all right? Quick way to tell. Some fractions you just ought to have memorized. not just because you're going to become a teacher in school, but because you're going to be a human being that lives in our civilization. You just should know this. So I'm going to make a list of, we'll put the fraction here, we'll put its decimal equivalent here, and we'll put its percent over here, and at some future date, in a timed situation, timed meaning you will not have time to divide the bottom into the top. You just need to know these. Here's one that I think you should have memorized. A half is what? I'm hoping you already have all or most of these. And what would that be? 50%. So when somebody says, well, you ate half of the, the pie, you go, oh, that was 50% of it, or that was 0.5 of it, or whatever. You should know that. I think you should know this one. 1/3 is 0.3 with a bar over it. Goes on forever. So what's the percentage? 33.3 with the bar over it percent, or you could go 33 and a third percent, either one of those, since 0.3 with the bar over it is the same as a third, right? Now, why is that important? How is it useful? You say to yourself, okay, there's, in the produce aisle, I find lemons, 3 for $1. How much is each one? Well, 3 for $1, that means $1/3 of a dollar. $1/3 of a dollar means how many cents? 33 1/3 cents, which when you go up to pay for one lemon, it will be really what? 34 cents, because they will always round it up. Okay? What if you bought 2 lemons? 66.6 with a bar over it, right? They would round it up to 67 cents. Okay? I think I'm going to only write the unit fractions. I think you should know 1/3 and 2/3. And you should know 3/3 too. That's real easy. 1/4. You better know this one. A quarter is, that's a quarter, right? 25 cents. And what? 25%. And if you know 1/4, you should know 2 quarters and 3 quarters and 4 quarters. So if I had 3 quarters here, you'd be able to fill that one in. Okay? What's this? 0.2 and 20%. And you should know all of the fifths. So if I say 3/5, you should be able to go, well, that's just 3 of these, that's 0.6, right? Or 3 of these, that's 60%, and so on. 1/6 is not nearly as common. I'm not going to require that you know that one. And 1/7 is even less common. I think this one we should know. What is it? Well, what's 1/8 of a dollar? 1/4 of a dollar is 25 cents. 1/8 of a dollar must be half of that. What's half of a quarter? 12.5 cents. 0.125. 12.5 cents, or 12.5%. Now you'll notice here that this column is identical to this column except for what? The decimal's been moved over 2 places to the right and a percent placed on it. If we're going to go this way, you move your decimal 2 places to the left and take the percent off, right? You can do that back and forth. So the 5/8 that the 3/8 that we have up here is just 3 of these, right? we have any cheerleaders in here that did cheering in high school or junior high? Okay, Mary Catherine's. Well, you've all gone to basketball games. Have you heard this? Maybe this is way back in my time. 2 bits, 4 bits, 6 bits, $1, all for, and then they put their high school name in. Stand up and holler. No? Raise your hand if you've heard that. I got to see. Oh, okay, so it's out there somewhere. All right. Where'd they get it from? 2 bits, 4 bits, 6 bits, $1. $1 is what? 8 bits. 2 bits, 4 bits, 6 bits, 8 bits, or $1. 8 bits, 12.5 cents is a bit. They don't exist anymore, but that's where it comes from. A bit is 12.5 cents. See, you're so young that none of this just, some of you hadn't even heard the cheer, let alone the, and some of you wondered, where did that song come from, or that cheer come from? Well, it came from an older monetary system that actually had...
When was that?
If I figure it out, go Google it. A bit. When did they quit doing a bit? Okay. All right. Last, no, not the last one.
It's also horses.
1/9. I need you to have this memorized. Do you have it? What's 1/9? 0.1 with a bar over the 1. What would 2/9 be? 0.2 with a bar over the 2. What would 3/9 be? 0.3 with a bar. Wait a minute. That's what this is. That's because 3/9 is 1/3, right?
Mm-hmm.
What would 5/9 be? So, 0.5 with a bar over the 5, right? So what would 9/9 be? 0.9 with a bar over it, right? Now what? Come on.
9 divided by 9 is 1.
What would 7/9 be? Let's see if you got it. 0.7 with a bar over the 7. What would 8/9 be? 0.8 with a bar over the 8. Check it out. 1 divided by, or 9, then 8 divided by 9, or whatever. Okay, so 9 divided by 9 would be 0.9 with a bar over it, right?
No. You round.
But we're not even rounding.
No, we're not rounding.
You're not supposed to round, that's the whole point.
Is the pattern true? Yeah. So that proves that, because we know this is equal to 1, right? So that proves that this is equal to 1. Doesn't it? Yeah. 0.9 that goes on forever is equal to 1. Now, if you stop somewhere down the road, it wouldn't be equal to 1, it'd be short of 1.
I remember this debate.
But if it goes all the way, come on, let's get back into our thinking about infinity and
It's
so on.
It was a huge debate in high school.
All right, what's this over here? 11.1 with a bar over it, percent, or 11 and 1/9%. Okay? This one, if you can't do this one, you shouldn't be at BYU Idaho because you can't even get your ecclesiastical endorsement because you haven't been paying your tithing, which is what? 0.1 with no bar over it, and it terminates. And this is 10%, which is the, okay. So you need to know not only 1/10, but 2/10, and 6/10, and 8/10, and 4/9, and 6/9, and 9/9. Okay. We're going to talk about that. What have we got? 15 minutes? Let's see where we need to go next. We have talked about how to turn a fraction into a decimal. How? Turn a fraction into a decimal. Any fraction, not these. These should be memorized, but how did you turn your fractions into decimals? Most of you divided, right? Divide the bottom into the top. We've talked about how to turn a decimal into a percent and a percent into a decimal. How do I turn a fraction, or excuse me, a decimal into a fraction? Let's do it. 0.37. Give me a fraction equivalent. 37 hundredths. How do you do it? How did you do that? It's easy. You say it the way your elementary teacher taught you to pronounce it properly. Don't say 0.37. That doesn't help you at all, right? And say it properly, 37 hundredths. Then you close your eyes and see it as a fraction. 37 hundredths. Right? That's how you do it. We can do this one the same way. 0.25. It's what? 25 hundredths. Close your eyes. You have 25 hundredths. Sometimes you have to what? Reduce it. Okay, simplify it. But that's how you do it, right? Unless, what if I give you this? 0.37 with a bar over the 7. Well, we already told you that every single fraction can be turned into either a decimal that terminates or a decimal that repeats. The opposite is also true. If I give you a decimal that terminates, you can turn it back into a fraction. And if I give you a decimal that repeats, you can turn that into a fraction. And we're going to hopefully remind you of this. I hope it's not the first time that you have this. Whoa, I almost unplugged somebody's computer, or
Oh, no, that's okay.
I almost pulled it off onto the... Okay. So, how do you do that? We're going to talk about converting repeating decimals. I'm going to show you one way. The homework tonight will talk to you about a slightly different way. I don't care which method you use, but whichever one you use, make sure you understand it. Let's take, let's go with 0.27 with a bar over the 2 and the 7. Okay, I want to turn it into a fraction. You ready? I don't know what it is, right? Actually, I do, but we'll pretend we don't. Do you know what it is? So, in algebra, when you don't know what something is, what do? Choose an x, okay? So we're going to set this equal to x, because I don't know what it is. And then once I find what x is, we'll know the answer, right? You with me? All right, so let's do this. Here's the procedure. I look at the repetend and I say, how many digits are in the repetend? 2. So since there are 2 digits in the repetend, I'm going to multiply both sides of this equation by the second power of 10. 2 digits in the repetend, that means I'll multiply both sides by the second power of 10. What's the second power of 10? 100. So if I multiply x by 100, I get 100x. If I multiply this number by 100, what's the result? 27. Is that it? Just 27? 27. I'm going to move the decimal, but this doesn't end. There's still what? 27s. So this is still going on, right? When I multiply this number by 10, I get 27.272727, right? Still repeating because this one had 2727. In fact, the 2, 7, the 2 7s, make these look like 7s here. Okay? Now, everybody see what we've done? Now, we're going to use, we're going to subtract the two equations. 100x, take away x, is 99x. Why are we going to do this? Watch, and here's why. If I subtract here, this 7 subtract this 7 is 0, 0, 0, and this zeros go forever because these repeat, but 7 minus 7, 2 minus 2, they're all going to be zeros, right? Except this 27. Minus 0 is 27. So I've got 99x is equal to 27. Well, I've almost got x alone. What have I got to do now? Divide by 99 on both sides. I get x is equal to 27 over 99. Can that be reduced?
Yes.
By what?
3.
3. Because 3 goes into the top how many times? 9. And 3 goes into the bottom? 33. Am I simplified all the way? Then we could have picked something bigger than 3, but that's okay. We can do it in steps. What? 3 again? 3 goes into there, 3 goes into there, 11. 3 over 11. I maintain that 3 over 11 is equal to x, and x was equal to 0.27 with a bar over it. Therefore, 3 over 11 is equal to 0.27 with a bar over it. To check this with your calculator, you grab it and you go 3 divided by 11, and what do you get? Do you have 0.272727?
Yeah.
All right. Yes?
Can we do one that only has one repeating digit?
Sure.
Just this.
Here we go. Let's do 0.27 with just the 7 repeating. That's a different number than this one, correct?
Yeah.
All right, do we know what that's equal to? No. So let's call it x. Now, how many digits in the repetend? 1. That means I'm going to multiply both sides by the first power of 10. What's the first power of 10? 10. So when I multiply x by 10, I get 10x. When I multiply this by 10, what do I get? Be careful. 2.7777, right? So I've got 2, and I'm lining up the decimals. 2.777, and this is going to be a 7, and these 7s go on forever. If you'll always multiply both sides of the equation by the same power of 10 as there are number of digits in the repetend, it will make it so that these all line up and cancel out. So let's subtract. 7 minus 2 is 5. 2 minus 0 is 2. 10x minus x is 9x. So I've got 9x is equal to 2.5. I've almost got x alone. What? Divide both sides by 9. We get x is equal to 2.5 over 9. We're going, yeah. I don't like this because I've got a decimal in a fraction, and how do we get rid of that decimal?
Same procedure.
What do you mean, same procedure?
You just take the decimal.
Hmm?
Will you just continue with just with the decimal part?
I want a fraction that's equal to the 0.27 with the bar over the 7, but I don't want decimals in it. Multiply the top and bottom by 2 would do it, or 10 would do it, and that makes it a little easier. In other words, what we're really going to do is we're going to multiply the entire number by 10 over 10. What's 10 over 10? 1. What happens when you multiply a number by 1? Nothing happens, right? Since 1 is the multiplicative identity. It does nothing. So therefore, the number I get when I do this should be the very same as I started out with, because anything times 1 is itself. And what do I get? 25 over 90. Is this reduced as far as it will go? No. How do we know? 5 will go into both. 5 will go into the top 5 times, and 5 will go into the bottom what? 18 times. Is that reduced as far as it'll go? Yes. Let's check it. Take 5 divided by 18 and see what you get on your calculator. It better be 0.27777 forever, right? Everybody see how to do it? While we're at it, let's go over here and investigate this right here. You guys don't think that 0.9 with a bar over it is equal to 1. So let's check it out. What is it if it's not 1? 0.9 with a bar over it. We don't know what it is, let's call it x. What's the procedure? Times both sides by 10 to the first, because we have 1 digit in the repetend. That gives us 10x is equal to what? Multiplying this by 10 does what to it? 9.9 with a bar over the 9. So these goes 99999 forever, right? You ready? This cancels all to 0. 0.9 minus 0 is 9. 10x minus 9x is what? 1x is 9x equals 9. We divide both sides by 9. We get x is equal to 9/9, which is equal to 1, which proves that if x was equal to 0.9 with a bar over it, that is equal to that. Okay. Part of tonight's homework will give you several fractions. Let's let you practice one. You ready? Everybody do this one. Find out what the fractional equivalent of 1/3/6 with a bar over the 3 and the 6 only. Find out what fraction it is equivalent to. And then check it after you get done.